I'm going to start by using the socket function. So I'm going to open the man page for socket. We can see we need to add 2 include files, so I'll just go ahead and include them. Let's see what I need to pass into the domain. So I'm just going to use AFINet. That means I'm going to use an IPv4 internet protocol. Afterwards, second argument is going to be the type. We can see we have a couple of types. I'm going to use sock stream. That's basic TCP connection. Finally, for the protocol, I can just specify 0. That will just use the default protocol. And that is well defined in this case. Let's go ahead and save this into a variable. And this returns an integer. So I'm going to save this as an integer. Just reminding that the code here is only for fun and for learning purposes, and it's definitely not production ready. After creating the socket, I want to go ahead and call bind to actually bind an address for the socket and a port number. So I'm going to open the man page for bind. First argument is going to be the socket file descriptor. Afterwards, you see that we need to pass some kind of pointer to a structure called sock address. So I'm going to go ahead and open the manual page for that. So you can see here the man page of sock adder. And we can see that we have a couple of types of structures right over here. I'm actually interested in sock adder IN, because this is the actual type that is relevant for IPv4. This also gets a port number right over here, and the address goes right over here. So this is the one I'm going to use. The first member of the structure is going to be the family. I'm just going to put it as AFINet. Second member is going to be the port number. I'm going to use the htones function for this. I'm going to use port 8080. Reason I want to use htones is because the byte order is not necessarily the same as the host. For example, I'm running here on an x86 computer, and x86 orders bytes in an opposite order than the network order. So this actually is short for host to network short. S is for short. That's the size of the port number. Finally, the last member of the structure is going to be the address, and I'm just going to keep this as 0. That means it's just going to be on all addresses on my current machine. Another important thing is we have here an include file that we need to add in order to have access to this structure. Let's just open the man page of htones for a sec. An important thing, we need to add in another include file for htones. So I'm going to add this right over here. Now let's open the man page of bind again. After defining the structure, I'm going to pass this as a second argument to bind. Finally, the third argument is going to be size of, and then I'm going to pass the structure. After bind, I'm going to call the listen function. So let's open the man page. First argument is going to be the socket. Second one is going to be the backlog. As we can see here in the documentation, the backlog defines the maximum length of which the queue of pending connections may grow. So I'm just going to give a magic number over here. I'm just going to define this as 10, but you can do whatever you want. After listen, I'm going to use the accept function. This will actually accept the client connection. First argument is going to be the socket. Afterwards, we have address and address length. But if you just scroll down a little bit, you can see that both can be null, in which case it will just not fill in anything. It's just if you want some additional information about the client connecting. I don't need this. Finally, I'm going to go to the return value of this function, so I'm going to scroll to return. As you can see, if everything is successful, it returns a file descriptor for the accepted socket. So this will be the actual client. After accepting, I'm going to actually start initializing the SSL. So the first function I'm going to call is SSL CTX new. And this will initialize the SSL context. Let's add the include file here. It only gets a single argument, which is the method to use, the SSL method. And as you can see in the bottom here, we have a couple of options for the methods. We have a lot of options. I'm just going to use the regular TLS server method. This function returns an SSL CTX pointer. After this function, I'm going to use the SSL new function. This will actually create the SSL structure, and it gets the context. Just going to pass the context to here. Afterwards, I'm going to use SSL setFD. And this actually connects the SSL object with a file descriptor. So I'm going to pass in the client file descriptor, so I can start talking with the client with the SSL. Afterwards, I'm going to use the function SSL use certificate, chain, and then file. We have a couple of functions here. I'm just going to search for the function I want to use. Here it is. Before actually using this function, I'm just going to go ahead and copy 2 files that I need for my server. So this is my actual server on the cloud. And I have initialized Let's Encrypt, so I have a couple of websites using Let's Encrypt. And I'm not going to go through how you can create a certificate with Let's Encrypt. It's pretty simple, and you can just find an online guide for this. So I'm just going to go ahead and copy the certificate from Let's Encrypt and the private key to my current folder. So let's start with the certificate. Notice I'm actually copying a file called full chain. Reason for that is I'm actually using a certificate chain file. So this file actually contains a couple of certificates, and it's basically from my server certificate until the certificate authority. You can read more about this online. Afterwards, I'm going to copy the private key. Now after copying both files, we can see that our directory now contains full chain and the key. So I'm going to start by calling SSL use certificate. Then we are going to use SSL use certificate chain file. And we can see here the documentation. First parameter is going to be the SSL object. Afterwards, we pass in the file path of the certificate chain file. That's going to be just full chain, as we can see right over here. Afterwards, I'm going to use the function SSL use private key file. And this function is going to be in the same document here, so I'm going to search for it for a sec. Here it is, SSL use private key file. We can see that we need to supply 3 parameters. First one is going to be the SSL object. Second one is going to be the file path. As we can see, the last parameter of SSL use private key file is going to be a type. So let's go ahead and find out what exactly we need to supply for type. As we can see, we can choose between 2 types. We have PEM and we have ASN1. In this case, the type is going to be PEM, so I'm going to specify SSL file type PEM. Afterwards, I'm going to use the SSL accept function. And this will actually wait for the client to initiate a TLS handshake. Just going to pass in the SSL object. Afterwards, I'm going to call the SSL read. This enables me to actually read bytes from the encrypted connection. Let's actually read 1023. And I'm going to initialize the buffer right over here. I'm going to initialize it all with zeros. Reason I'm only reading 1023, even though it's 1024, is I want to keep one null terminator in the end. In order to keep this simple, I'm only going to support the GET request. So I'm going to assume it's going to look something like this. Get and then slash something. And then the rest right over here. And so I'm going to skip get right over here and just go ahead and check what file it's requesting. So I'm going to skip 5 characters from the start. In this server, I'm only going to support requesting index, so every other file it's just going to return some kind of error. And so I'm going to use the str compare function, strcmp. I'm going to actually use the str end compare, so it gets a size in the end, so it doesn't go too much. For the first argument, I'm going to pass the file request. The second argument is going to be index.html and then the space. Last argument is going to be the limit of the comparison. I'm just going to pass in 11 bytes because this string contains 11 characters. Now let's talk about the return value. So we have the section here talking about what exactly it returns for which cases. We can see that it's going to return 0 in case both are equal. So I'm just going to check if it's 0. In this case, I'm going to actually open the file. And for this, I'm going to use the fopen function. Let's add the include file. First argument is going to be the path name. Afterwards, the mode. I'm just going to open this for reading, so I'm going to pass R, as we can see in the man page right over here. It's going to return a file pointer. After this, I'm going to call fread. And another important thing is I'm going to go back here and define another buffer, which will be the response. And I'm going to call fread and pass in the response buffer. Actually, before passing in the size, I'm going to do another thing here. Before passing the size argument of fread, I'm going to go back for a sec to the response here, and I'm going to add something before actually sending the file. I need to add a couple of HTTP metadata. So for this, I'm going to open the manual page of memcopy, and I'm going to define a string over here. I'll call this metadata. This is just a little bit of HTTP metadata I need to add before sending the actual contents of the HTML. I'm keeping this as simple as possible to make it work on Chromium-based browsers. I'm going to test this on Edge. This might not work on your browser, in which case you'll probably need to add some kind of HTTP header. I'm just going to use a single header after this, which is content type. I'm going to specify this to be text HTML. Now let's go ahead and copy this to the response buffer with memcopy. I'm going to use the strlen function to get the size of metadata in bytes. Another important thing for memcopy and strlen and all the string related functions, I'm going to add the include file string.h. Now let's go back to the fread function. And for the size, I'm actually going to pass the buffer size minus the size of metadata. I'm also going to add another minus for this, -1, just to keep one null terminator in the end. Number of members is going to be 1. So I'm going to read one block of this size. Finally, the file, I'm going to pass the file in the last argument. Afterwards, I can use the fclose function. Another important thing is I want to write to response plus strlen of metadata. So I won't go ahead and overrun the metadata that I just wrote. Now let's handle the else case. So if it's requesting any other file besides index.html. After I finish preparing the response buffer, I'm going to go ahead and call the SSL write function. And this will enable me to actually write bytes on the secure connection. First parameter is going to be the SSL object, afterwards the buffer I want to write, finally the number of bytes. I'm going to finish off by calling SSL shutdown. Before running, let's go ahead and fix a small bug in my code. As you can see, in the case of an error, I need to memcopy response plus the strlen of metadata, so it won't overrun the metadata. Now let's go ahead and save this. I'm going to start by compiling this with GCC. First pass the C file, and then I'm going to use the -l flag to specify a custom library I want to use. In this case, I want to use the SSL library. This is the OpenSSL library. Before running this server, I recommend that you only allow connections to this port from your home IP address. And this is because this server is not really ready for production, and it's just for fun, and this is just a security measure. So I just did this in my cloud provider, which is called Vultr. I went to the firewall feature and I opened port 8080 only for my IP address. I'm going to show you real quick what index.html contains. It just contains hello from near server. Now let's go ahead and run this. Now let's go ahead and browse to the actual HTTPS server that I just started. So I'm going to browse to my website, and I'm going to go to port 8080. And let's start by requesting index.html. And you can see that this works nicely. We get hello from near server. And it's secure, as you can see right over here. Now the server exited, so I'm going to start it again. And this time I'm going to request a page that does not exist. And as we can see, we get the error message right over here. No page found. Subscribe for more programming videos, and thanks for watching.